Good morning, grade 9 students. Our today's topic is irrational number. A number S is called irrational if it cannot be written in the form of P by Q, where P and Q are integers and Q is not equals to 0. Yesterday we have discussed about rational number, where the rational number is also which can be represented in the form of P by Q, but irrational number cannot be represented in the form of P by Q. There is one little difference between irrational and rational. The rest all the things are same. Let's see the example. Root 2, root 3, root 15, pi and this number, they are the examples of irrational number. Why we are writing root 2, root 3, root 15? Because the value of these roots, root 2, root 3, root 15, what pi, are non-terminating and non-repeating numbers. Non-terminating means when we will divide it, it will not terminate, and non-repeating means digit in quotient will not repeat in the same way. Like you can see here 0.10, then 110, then 1110. In the same way, the digits will not repeat in the same manner. So these are called the irrational numbers. Let's talk about real number now. The collection of all rational and irrational number is called the real number. अगर हम रैशनल और इरेशनल को कलेक्ट कर लेते हैं तो उन सारे नंबर्स को हम रियल नंबर्स कहते हैं. सारे नंबर्स रियल नंबर्स कहलाते हैं, विच इज़ डिनोटेड बाय कैपिटल आर. रियल नंबर्स को कैपिटल आर से डिनोट किया गया है, ये इसका सिंबल. एवरी रियल नंबर इज रिप्रेजेंटेड बाय अ यूनिक पॉइंट ऑन द नंबर लाइन. Also, every point on the number line represents a unique real number. Means you already know about the number line where we represent the integers, whole numbers, natural numbers. In the same way, there is one real number line also where we represent the real numbers on the line. So how we can represent the root numbers or irrational numbers on the number line? Let's see the example. The question is locate root 2 on the number line. So how can we locate the root 2 on the number line? How can we represent? Let's see the process. First we need to draw a number line like this. 0 in the middle, then positive numbers on right side and negative numbers on left side. Now we have to use here Pythagoras theorem for finding out root 2, where it will locate. So first of all, we have to take the equal distance between all the numbers, like 0 to 1, 1 to 2, 2 to 3. These all are the equal units. You can take the 1 centimeter gap between them, then place the protractor on the point A, and you need to draw a right angle. You need to draw a right angle and draw one straight line, perpendicular line here, like this, AB. You can see here AB is a perpendicular line which is also of 1 unit, like this. The distance of OA is same as distance of AB. Why we are taking the same distance 1 and 1, I will tell you later. Then join point O to B. This would be the hypotenuse. You can see here OAB would be the right angle triangle, and OB, the length of OB would be root 2. How it is root 2? How we can tell it is root 2? Just I will tell you later by using Pythagoras theorem. Now the distance of OB would be the root 2. So just take the compass and put the pointer on point A. Then take the radius of OB. Then draw one arc like this. So this would be the arc B to P. So wherever the point P will form on the number line, it would be the root 2, which is lying between 1 and 2. That means root 2 is lying between 1 and 2. It is greater than 1 but less than 2. You can show it, you can locate it here. Point P is the root 2. Now why we are using Pythagoras theorem? Look at here. OB square equals to OA square plus AB square. This is because of Pythagoras theorem, because we have seen here OAB is a right angle triangle, so we can put Pythagoras theorem in right angle triangle. Now OA we are taking 1 unit, AB is also taking 1 unit, so we have just put it here 1 square, 1 plus 1, 2. Now OB square equals to 2. That means OB is equals to root 2. So OB would be the root 2. In this way, we have found distance of OB equals to root 2. So in this way, we can locate root 2 here on the number line. So this is the real number line where we are representing the irrational number, like we have represented root 2 here. In the same way, we can locate root 3 also on the number line. In the same process, first of all, we need to locate root 2 like this, as we have represented root 2 here. In the same way, you have to first represent root 2 here at point P. Then OB would be the distance of root 2. Then we have to put protector, keep protector on line OB and draw a perpendicular line from point B to D. So BD would be the perpendicular of OB. Then join OD. Now we are taking BD as again 1 unit, like AB we have taken 1. In the same way, BD is also would be 1 unit. Now we have to join OD. So this would be the root 3 distance. How? Because of the Pythagoras theorem, you can see here OBD is a right angle triangle again. So OD square equals to OB square plus BD square. Hypotenuse ka square equals to perpendicular square plus base ka square. Now we have solved it. OB is root 2. You can see here OB was root 2. Here also we have found root 2. Here also we have found root 2. So root 2 square plus 1 square. That means 2 plus 1 equals to 3. So OD would be root 3. So you can see here OD, the distance of OD would be root 3. So if OD is root 3, just put your compass here on point O, then take the radius of OD and cut it and draw one arc DQ. You can see here DQ is the arc. Q is representing root 3 on the number line. It is also coming between the 1 and 2. So we will write here root 3 is greater than root 2 and 1 but less than 2. In this way we can locate root 3 also. In the same way we can represent many rational numbers on the number line. So all the rational numbers on the number line we can, but this time we are dealing with roots values, root 2, root 3, root 5, whatever. So thank you so much for today's topic. Thank you.